Okay, hello everyone, welcome. Can you hear me? Hello.
Yes, we
Yeah,
can
how are
hear
you?
you. Alaikum. Good afternoon.
Walaikum assalam. Good afternoon. Yeah, how are you?
It's been a while. I'm fine, alhamdulillah.
Yeah, Alhamdulillah, everything is good. Okay. Okay, so let's go start. So after completing the live session, then talk about the problem solving class for the previous classes. Okay. So I'll got some problem from you. So I'll also try to explain this type of problem. Okay. So let me share my screen. Okay, can you see my screen? Is it visible?
Yes, yes, please.
Okay,
Yes.
thank you. So let's go start. Okay, so basically today I discuss about the three topic, mainly how we can easily work with the susceptibility mapping, mainly landslide hazard mapping or landslide susceptibility mapping. Okay, help of machine learning. Okay, and combine the different types of factor and to identify the landslide prone area. Okay, as well as we also discuss about that flood mapping, mainly Sentinel one star data. So this thing we already discussed in our 7 days training session. So for that, I discuss about the machine learning. So how we can easily add the machine learning and identify for the flood prone area. Okay. And also discuss about that agricultural land suitability. Okay, how we can easily identify agricultural land suitability, integrate with the different types of factor such as soil factor, then slope, climate, different types of climate factor, suppose rainfall, temperature. So this type of factor, how we can easily integrate and help of the machine learning, how we can easily detect the suitable crop zone. Okay, so basically today we discuss about the mainly suitability analysis, help of machine learning, as well as also susceptibility mapping or hazard mapping, how we can easily identify for hazard. We also discuss about that. So let's go. Okay, first of all, we discuss about the some scientific paper regarding this type of topic, then jump to our today's session. So let me show you some paper regarding this type of topic. Just a minute. So simply visit Google Scholar. Simply search here, suppose flood susceptibility assessment using machine learning. So you find out different types of model. You can see this is the flood susceptibility modeling using the advanced ensemble machine learning model. They use support vector machine. This is the integrate the machine learning method with the resampling algorithm for the flood susceptibility prediction. They are also used. So a lot of work already done using this type of paper. You can see using the flood susceptibility. So this is the perspective of Bangladesh, flood susceptibility assessment in Bangladesh using machine learning and multi-criteria decision analysis. So if you check this paper, let me open. So in this paper, if you check, they are used at the MCDA. Okay, MCDA basically a multi-criteria decision analysis. Okay, they are used the two analysis. One analysis for MCDA. MCDA mainly it's called the multi-criteria decision analysis. Another apply is that machine learning. Okay, basically they are apply the support vector machine and they are identify for flood prone areas. Okay, and if in this paper you can see that use at the artificial neural network, basically ANN, and also use the ASP method. Okay, also use the logistic regression, mainly RN, and also frequency ratio FR. So they are use this type of things and then identify for the flood hazard or flood susceptibility mapping for the whole country boundary of Bangladesh. Okay, they are used there, and this is the flood inventory map. Okay, so you can see this type of green color indicating about that non-flooding areas, then this type of red color indicating about that flooding areas, and this type of color indicating about the river network. Okay, So now this type of things in this paper, they are combined MCDA, multi-criteria decision analysis, as well as they are also used at the support vector machine. Okay, identify the flood prone area and then create the flood inventory map. And if you check, they use this type of factors, suppose rainfall. Okay, then also use the elevation, then slope, then land use, land cover. They are also used at the geological data, geology, then soil tract they are also used. Then also I use the drainage area, then flood depth and flood duration. Okay, so they are use this type of data and also use their method. Okay, how to collect this type of data if you check. And they are apply the model approach, they use the artificial neural network and then identify the flood prone areas in Bangladesh. And if you check, this is type of map they are create. So this type of data, so this one is for elevation, this one is for the slope degree unit, this one is for rainfall, this one is for the depth, this one is for drainage area or drainage density, this is the flood duration mapping. Okay, flood duration. And if you check, this is the soil tract or soil information, this is the land use, land cover. Okay, so this type of factor they are used to create this type of model. And finally they are used at the ASP, basically analytical hierarchy process, ASP method they are also used, okay, to identify and then integrate the model with machine learning. So if you check, this is the follow chart about that. So these are data source that use at the dam data, then physiographic data, then use the drainage data, satellite data, flood investigation data, then existing flood data or recorded flood data they are also use, and hydrological data they are also use, and find out the flood inventory map. Okay, and then use the training data set 70%, testing data set 30% they are also using here. And finally they are apply the, you can see in this time they are apply the artificial neural network, then also apply the ASP method, then LR, FR. So they are used a lot of method, you can see. And this type of method mainly compare, suppose which model provide the better accuracy, they are also used. But in this time I just show you the machine learning, how we can easily apply the machine learning, suppose random forest, this type of machine learning, how we can easily apply, and then how we can easily identify flood susceptibility mapping. Okay, and then check the accuracy. And they also use this type of, you can see, flood condition factor, different types of conditions, suppose rainfall, elevation, slope, land use, land cover, then geology, then soil tract, then drainage area, then depth, then flood duration. So this type of factor they are also used, okay, for identify flood condition. They are also use this type of factor. So we also use this type of factor also in our study area and then identify. And they also apply the ASP model, but in this case we are just work with the machine learning. Okay, machine learning and then identify for the flood prone area. So this is the final map. There you can see that this is the result for that LR and FR. Okay, this is the result for basically LR. Okay, LR method. This is the result for artificial neural network. This is the result for FR, frequency ratio. Okay, this is the result for ASP method. So you can see different types of model. It provides the different types of flood inventory map we find out for this paper. And further they also calculate the accuracy for each model and then display this type of research paper. Okay, so this is the one kind of paper that use the flood susceptibility or flood hazard mapping using the machine learning, and also use the MCDA, mainly multi-criteria decision analysis, that also used in here. So let's try to show you the flood mapping first, then we talk about that landslide. Okay, landslide is also same process, and also talk about the agricultural land suitability. Here I already completed work for this area for identify flood susceptibility for this region of interest. So I will try to explain one by one, then get a more better idea. So in this case, first of all, we need to set some flood condition factor. Suppose land use, land cover is one kind of factor. Then soil type, then topographic wetness index. Okay, topographic wetness index, it's also a very important factor for the flood. Then drainage density, then lithology. Okay, lithology mainly geological information. Then SPI. Okay, then this is the study area, mainly flood area. So first of all, I try to show you this type of data. Then we just show you the process, how we can easily make So in this time here I just add the SPI, lithology, drainage density, topographic wetness index, soil type, land use, land cover, and this is the NF, basically not flood area. So it's a training sample. Okay, not flood. Suppose this type of place is not flood. Then suppose this is the low, very low, and this suppose very low, low, high. Okay, so this type of factor basically it's a training sample, mainly point. Suppose this GT, it's one kind of a variable. If this variable is stored the training sample, suppose very low flood occurrence, it's stored the flood occurrence data. Suppose G2, suppose low, then high. Okay, very high. And this NF basically not flood. This type of place there is no flood, because in this case we are applying the machine learning, so then we need this type of data. And this type of data, suppose non-flood area, then very low, very high, this type of flood area, when you it's a one kind of occurrence data. So this occurrence data you can collect from the historical flood analysis. You can also collect this type of data for your study area and then use it, because in this case we just identify flood susceptibility help of machine learning. So machine learning you must need the training sample or pre-categorized data. So now this is the GT. Suppose this GT is the very low, then it's a high, and GT suppose very high, and NF basically not flood. Okay, not flood region. So then this type of factor we also use. Suppose land use, land cover factor. Okay, then soil type, then topographic wetness index, it's another factor, then drainage density, then lithology, then SPI, basically stream power index. So it's one kind of index, and this type of factor you need to create. It also possible. Suppose you can easily make the land use, land cover mapping help of machine learning in your study area. Okay, then soil type, so we can also use the soil type data we can also get from the Google Earth engine easily. Then topographic wetness index, then drainage density. So this type of factor, if you want, you can also use the ArcMap or QGIS software for your study and then make, and then GeoTIFF file format simply import in the asset tab. So in this case here I already create, suppose land use, land cover for this study area, then soil type, then topographic wetness, then drainage density, then lithology, then stream power index. Okay, this type of things I already create for my study area. So now I can easily import it from my asset tab, this type of factor, because this type of factor I just use and make the flood susceptibility help of machine learning. Okay, so now if you try to check, suppose, okay, so first of all let me show you my study area. Suppose just display the study area. So just I add a layer, add layer of my study area, use the table and run the code. It's working. Yeah, so this is my study area. So for this study area I want to identify flood susceptibility mapping, and we want to identify where is the high flood, where is the low flood. Okay, this type of flood prone area we try to identify. So this is my study area and I want to use some factor. Suppose if you check, I just use the DEM data, so we can easily get the DEM data from NASA SRTM, USGS NASA. So this is the DEM data, and I just also get the slope. Okay, so we are just use the e.train.slope and call this DEM data, and from the slope we simply calculate the curvature. Okay, so just call the DEM data, put the focal mean 3 and subtract with the DEM data, then you can easily find out the curvature. So if you want you can also add the layer. So this type of data, suppose map.add layer of DEM. So just try to add this type of layer. So now you can easily get the DEM data for this study area. And this thing we need to clip with the study area. So just clip with table. Table is my ROI. It is stored at the shapefile boundary. If you want to also add the color to identify to look more better for this result. and then add the color. Suppose low elevation show this type of blue color, greater than show this type of yellow color, and high elevation show this type of red color. So now you find out this type of elevation map for my study area. So this type of place we find out the high elevation. Yeah, this type of place. So this is the map for the elevation or DEM data. Just import. Okay, it's optional. Okay, it's not mandatory to work with. So it's optional. If you want, you also visualize this type of map in Google Earth Engine. This way, simply visualize and put the layer name. It's a DEM. Suppose then I want to display for the slope. So same process. Just I copy the same line of code and add the slope map. Just copy and add the color. I also put its layer name is the slope and run the code. We find out. So now I stress this data. This layer simply stressing, and this unit is the degree. Suppose if you want to add the color, apply. Then import. So this is a slope map. Just copy the visualization parameter and paste here. So this is a slope and curvature. If you want to add for this, just same. Just paste the same line of code. Just copy and add the curvature layer. So this we created from DEM data. So now run the code. So now it's added the another layer, curvature. So now add the color for the curvature layer. And then apply. So then we find out this type of curvature map and also import this visualization. Then copy the visualization parameter, the curvature, and paste here. Okay. So now run the code. Okay, so we find out this type of factor. Suppose this one is for the curvature, then slope, and then DEM. Okay, you can easily create from the DEM data this type of factor. Okay. Then if you want, you can also add suppose other. Suppose here I already added. You can see the land use land cover. You can also add the display the map. Okay, or soil type or topographic wetness index. Okay, just add the layer. So let me show you that also. Then you can get the better idea. Just add the layer. So map dot add layer of, suppose I'm going to add for land use land cover. clip with study area, which is stable. So now run the code. So further add the color for a specific land use land cover. Or if you want, you can check, suppose you can check the, okay, so this, how many class in this land use land cover. So that's click on here, and then you can easily get the information how many classes in this land use land cover classification image. From the bands we can get this type of information. Click on the bands. So here we find out that nominal scale 0 to 4, 0 to 4, it means that there are total 5 class: 0, then 1, then 2, then 3, then 4. Okay, 0, 1, 0 to 4, this is the minimum and maximum. So just 0 is one class, 1 is another class, 2 is another class, 3 is another class, 4 is another class. Okay, 0 to 4, this is the minimum and maximum value. So you can also add the color from here. Suppose just add the color. Suppose just add the mean is 0 and max up to 4, and then add the color plated. Okay, suppose 0 is for water, 1 is for build up. So just simply add the different types of color for a specific class. So in this case, suppose I put here the blue color. Suppose 0 is water, I put the randomly because I forget the color which class is stored which. So then I put here suppose green color. Okay, then I put here suppose red color. Okay, then I put here suppose yellow color. Okay, suppose then I put here the black color. Okay, 1 2 3 4 5, because total 5 class I put the 5 different color. So now I put it, it's a LULC. Okay, so when you import the LULC and you want to, you can just apply the same process and visualize your land use land cover, okay, in a layer. So we find out this type of land use land cover map. Okay, I think it's some mistake in the color combination. Okay, so in this time I just randomly I put here 0 to 4 different color. So this is the land use land cover information is simply add. Then if you want, you can also add here the soil type. Same process, I want to add the layer of the soil type. Soil type, click with the study area which is stable, and run the. So now you find out this type of soil type information. If you want to check, if you check the band information from this image, sorry, it's a soil type, and click on the bands, then we find out that how many soil type class in this image we find out. Then click on the bands. So 1 to 4, so total 1 is one class, then 2, then 3, then 4. Okay, so we find out the total 4 class: 1 2 3 4. So 4 types of soil we find out in this area. So just we have to add the 4 different color to identify different types of soil type. So just put here, start the curly bracket and put the mean, it's 1, up to max, it's a 4, and put the different types of color to identify different types soil type. Suppose I put the manually. Suppose one is I put here. Suppose one is the blue. Then another soil type I put here. Suppose green. Then put here the yellow. Okay. Then put here suppose final. I just put here another is for white. And I put the layer name. It's a soil type and run the code. So now it's added the soil type information. So now if you check, we find out this type of map of soil type. And finally, if you check the topographic wetness index, TWI, this is another plot factor. We'll add, suppose map.add layer, TWI, click with my study area, which is table, and run the code. So if you check, we find out this. If you want to use that the color for the TWI, the topographic wetness index, just stressing 98%. And then add the color plated for, suppose this is the low, gated, then I just use this type of green color, then gated, then I just use this type of yellow color, and high topographic wetness index display this type of red color. Just apply. And then further just import this visualization of topographic wetness index. Just copy and add this visualization and add the layer name. It's a TWI, topographic wetness index. So now it's added this type of topographic wetness index. So this type of red color indicating about the high topographic wetness index. Yeah, this type of visualization. And mainly when you work with the research paper or scientific paper, we need to, this type of GeoTIFF file we need to create. Okay, and when you create the GeoTIFF file, just simply make the map for your research paper. Suppose every factor, every flood factor, we need to create this type of map. Okay, soil type map, land use land cover map, curvature map, slope map, dam map, soil type map, topographic wetness index map. So every map we need to create. So when you work with the research paper for your study area, and then you can easily add the legend title. Okay, but in this time I just show you for the visualization. Then suppose I want to add for another layer which is lithological information or drainage density, this layer. So this type of things I already created in my ArcMap or QGIS software, or even Google Earth Engine. You can also use this type of factor you can create, and then simply export as a GeoTIFF file format. So I want to add the this layer drainage density map dot add layer and paste drainage density, click with the study area which is table, and run the code. So this is another factor for flood drainage density. Now if you check, just add the layer color for the drainage density. I was going to add this type of blue color for the low density. Then get it, then I use this type of green color. Get it, then I use this type of yellow color. And high density, I want to use this type of red color, indicating about the high density, high drainage density area. Just apply. Then import this visualization and copy this. Copy this variable of visualization, drainage density, and then put the layer name. Suppose it's a drainage density. So we find out the another vector for plot. Then lithology information. Just add the another function map.addLayer and add the layer of lithology. Click with the study area. This is stable, and now run the code. And if you check how many class in the lithology, click on the and check the bands. And we find out that how many class, basically 1 and 2. Only for the 2 class we find out 1 and 2. So just simply add the different 2 color to identify the different 2 geology map or lithology map for this study area. So just I use the visualization. Suppose just add the lithological information. I want to add the make a dictionary. Suppose mean is 1 and max is 2, and add the different 2 color plated. Suppose I just one color for the blue, another color I want to use, suppose red. So they are the 2 geology information. I put it's a lithology. So now run the code. Oh, we need to add it after the second curly bracket. We just add it after the curly bracket. So now run the code. So now we find out the lithology map for my study area. So we find out, you can see this is the 2 color we find out. So these are 2 class of lithology. So this is the one class, this is another class we find out. And then if you check, another one is that SPI, stream power index. So this is another index, and it's very important factor for flood. SPI index, stream power index. So just add the layer for stream power index, SPI. Clip with the study area which is stable, and now run the code. So it's an index. You can easily tracing and then add the color to identify where is the high stream power index, where is the low stream power index. So you can easily get this type of information. So now I'll just add the color stream power index. And add the color. Suppose low, I want to display this type of blue color for the low stream power index. Get added, then I show this type of green color. Then use this type of yellow color. And high stream power index, I just use suppose this type of red color. It's indicating about the high stream power index. So now you find out this type of map, okay, for this stream power index, and then import the visualization and further add. Just add. And then put the layer name, it's a SPI. So basically this type of factor we are just use for identify flat front area, help of machine learning. So you can see, suppose we need the dam, then slope, then curvature, land use, land cover, then soil type, topographic wetness index, drainage density, lithology, and stream power index. This total 9 factor we are just use, and then further we try to identify plot susceptibility mapping for our study area. So basically when you work for your own study area, for your research paper or scientific paper, then we need to manage this type of data. Okay, we can easily manage, it's not very hard. So we can easily create the drainage density, lithology, stream power index, then dam, then slope, okay, curvature, land use, land cover. So this type of, this is the SPI, this is the lithology, this is the drainage density, this is the topographic wetness index, this is the soil type, this is the land use, land cover, this is the curvature, okay, this is the slope, this is the dam. So basically this type of factor we are just use to identify for flood susceptibility. Not only for that, we also need to another factor which is very important. It's called the precipitation, mainly rainfall data. Okay, rainfall data is very important to identify for flood. Okay, so we also try to also add the precipitation. Okay, as well as we also need the some other data. It's called the ground data, or it's also called the occurrence data, flood occurrence data. So if you check here, I already imported the GT, GT2, GT3. So 3 different flood occurrence data. Suppose GT, it's very flood, very low occurrence, then high, then very high. And NF is the not flood. So if you want, you can also add this type of layer to display this type of point. It's a one kind of point. So if you want, you also add this type of point. So let me show you that how we can add this type of point. Just add the layer, map dot add layer of GT. Okay, and I put the, it's a, I put the color. Suppose I put the color is the red, or put the suppose blue, and I put, it's a low. So now run the code. So now it add all of low flood occurrence point for my study area. So you find out, you can see this type of point, it's a low flood occurrence, this type of point we find out. Okay, it's one kind of training sample for the low flood. So then I just add that a high flood occurrence region or point. Suppose map dot add layer. So it is straight the GT2. I put the color, another color to display. Suppose I put that blue green color, and I put land name, would say high. So high flood occurrence, this type of green color indicating this type of point. So you can see find out this type of point. So if you zoom, then get the more better idea. Okay, find out. Let me zoom. Okay, it's overlay high and low, two sample. Okay, some this another sample. Okay, just let me open only for this layer. Okay, find out. Yeah, so this is the low blue color. Okay, this type of place is that high. Okay. Okay, now let me add suppose very high point, then check what happened. So map.add layer. It's a GT3 and put the color. I put the color suppose red. It's a very high flood occurrence. And also add the another not flood or non-flood area. So it's stored the information in the NF. Okay, not flood. NF. So I put the color is yellow. And it's a non-flood. Now run the code. So now you find out, you can see this type of yellow color, this type of red color. So all of training sample you can easily find out. So you can see you find out this type of yellow color, this type of green color, red color. So was very low, then high, then very high. This type of red line getting over the very high flood prone area. Okay, and then this type of place we find out the non-flood. Okay, so these are training sample for the total this type of color. So low, flood, then high, very high, and non-flood. Okay. So after that, we also compute the some other factor. Suppose NDVI, we also try to add for the study area, because vegetation is another factor for flooding. Suppose why do we find out the high vegetation, this type of place, mainly we find out that low tendency for flood. Okay, for the high dense vegetation. So for that we also add the NDVI. So for the NDVI, we are just applying the Sentinel-2 satellite imagery. So this code you already know about that. So this is the function to removing the cloud for your study area from the Sentinel-2 satellite imagery. So in this case, this is the band name QA60. Okay, this is the band name. So this band have the 2 bit 10 and bit 11, mainly cloud and cirrus cloud. So this 2 cirrus cloud we simply set equal to 0 signal. Okay, 0 signal indicating about that clear condition of the satellite imagery. So just we simply apply. So this is the function. So this function further we need to connect with the your image collection. So this is my image collection. I simply add, okay, just I simply put in here. So this is my image collection. I simply connect this function. This is the function variable name. Okay. So I take the year 2023. Okay, this time. Okay, and this is my function variable name. I just connect with my image collection to remove the cloud and haze from my satellite imagery. So then further I simply compute the median and then make the normalized difference between the near infrared band and red band. Okay, so basically near infrared minus red divided by near infrared plus red. So when I apply the normalized difference function, this function automatically computed this type of equation. So now if I want, you can also add the NDVI map for my study area. So just apply map.add layer and then call the NDVI, okay, NDVI clip with study area, which is table, and run the code. So now we can get the information about the vegetation for our study area. And this NDVI we also use as a factor for flood. So now if you want, you can also add the color to identify your vegetation. Suppose just click on here and add the color. I'll just stress the data. So stressing 98%. And add the color, suppose color plated. Suppose low vegetation, show this type of color. Then get it, then I will show this type of color. Then get it, then you show this type of color or this type of color. Then high vegetation show or high dense vegetation show this type of dark green color. I just put and then apply. So now you find out this type of vegetation map. Okay, so basically this type of green color indicating about the vegetation area. You find out, okay, this type of green color, it's a vegetation. It's a vegetation. You find out and import this visualization and copy this resolution parameter. Just copy the variable name, this one, it's NDVI. And then connect this layer and add the layer name, it's a NDVI information. So you find out another factor for NDVI. So this NDVI you compute from the Sentinel-2 satellite imagery, Sentinel-2 surface reflectance satellite imagery we are just use and then compute. So you find out this type of NDVI information or vegetation map for this study area. Okay. And now we also need to add the another important factor. It's called the precipitation or rainfall. Okay, rainfall is very important factor. So further we can also use the sharp satellite data. So it's a sharp spanted satellite data we are just use. So I take a variable, suppose rainfall, okay, and call the image collection. Okay, it's a sharp spanted satellite imagery. Okay, and I just put the same time period. Okay, and I rename as a rain and I calculate the total rainfall, okay, for this time And if you want, you also just add the layer, where is the high rainfall, where is the low rainfall. You can easily get this type of information from this map. So just add the rainfall and then run the code. So now it's added the another layer of rainfall. We need to just click with our study area. Suppose click with table. So now if you want, you can also add the layer to identify where is the high rainfall, where is the low rainfall. You can easily get. Suppose just stressing 88%. So then add the color plated. Suppose I just add the low rainfall. Just use this type of red color. Then get it. Then use this type of yellow color. Then use this type of, and high rainfall. Just use this type of. Suppose I just use this type of color. And high rainfall, I use this type of blue color. And apply. Just copy and add after the layer name. Just paste here. And then put the, it's a rainfall. So now we find out this type of map. So this type of place is the low rainfall. Okay, this type of blue color indicating the high rainfall, and it show this type of grid or cell because it's a sharp satellite data which is 5,500 meters pixel size. Okay, so that's why if you want to use the another data source for the precipitation rainfall, it's really more better. Okay, because in this time you can see it show very enlarged pixel size. So if you want, you can also get the different types of data. Suppose a meteorological department for every country, we can get some precipitation data or rainfall data. So if you want, you can also use this type of data and create the more better rainfall map, okay, or precipitation map, and then just apply the IDW, okay, interpolation method and create. Okay, then it will be more better to work. But in this time, you just use the sharp satellite data. It's globally available. But when you work with your own study area, you try to use the meteorological department data, okay, for the precipitation or rainfall to create the more better precipitation map. Now it also work. You can see we find out this type of place is the low rainfall, okay, and this type of blue color indicating about the high rainfall or high precipitation. Okay. So now we set the different types of factor, okay, basically rainfall factor, then NDVI, okay, and also add the different types of flood occurrence data. Suppose low, high, very high, and non-flood occurrence point. It's a point data, and also use this type of flood factor: dam, slope, curvature, then land use, land cover, soil type, topographic wetness index, drainage density, then lithology, steam power index. Okay, so now we need to add the So basically this type of data is the different types of resolution. Okay, suppose some data set is the 30 meter, some data set is the 5000 meter, and this sentinel-2 is the 10 meter. So we are just use the different types of pixel size for the different data source. But when you apply the machine learning, we need to keep the same all of data set. We need to add the same pixel size or same resolution. So for that we need to add the common grid. Okay, common grid to optional, but it's recommended because in this time we are use the different types of data source for the different satellite imagery. Okay, so in this case we are just keep the all of common grid. Suppose 30 meter, we are just consider the 30 meter all of common grid for the time, slope, curvature, ndvi, rainfall, all of data set. We are just take the 30 meter pixel size and then take the extract the training sample or extract the points pixel values. So for that we simply use, suppose just take a variable, suppose this is our target projection scale, dem data is 30 meter. So I want to use the 30 meter for all of data source. Okay, all of data source, I just keep the scale 30 meter. So for that, suppose dem 30, I just take a variable dem 30 and call the dem reproject crs using this target project. Okay, which I already do it the projection 30 meter, it's a 30 meter dem, so that I set the scale 30 meter. Then slope, it is the 30 meter, then curvature, okay, then ndvi, okay, then rainfall. So all of those we simply keep the 30 meter resample by linear method. Okay, and keep the scale 30 meter. And then we simply set some just simply connect all of prediction bands. If you check all of prediction bands, we take a variable, mainly just connect with each other. Suppose you can say e.image.cat and we simply connect. Suppose tem 30, slope 30, curvature, ndvi, and rainfall, we simply connect. Okay, and clip with our study area. And we take the flood points, suppose table 2, and yeah, you can check the level integer, we find out the class level. And from here, okay, so in this time I think we need to mistake in here, so we need to connect not only for the one flood, because if you check gt2, gt3, so all of those we need to merge. Okay, all of those sample we need to merge and extract the information. So for the simple write in here, suppose gt merge with gt2, then merge with gt3. Okay, and then also merge with non-flood. Okay, this was training sample, all of training sample. And further we simply take the flood points randomly, we take the training and testing randomly. And now we apply the sample regions to add the training data. So just we try to print and check the training data. Just copy and paste and check the result. Okay, it's working. Let's check what happened. So now if you check, click on the feature collection and click on the feature, so you can see total 1754 training sample. And this type of training sample extract the this type of property. You can see the ndvi, curvature, then dam, then rain and slope. So this is my prediction band, this type of class 1. If you check, total 1700 something training sample. So it is track this type of information. Okay, So now further we simply apply a machine learning model. It's called the random forest. We are just applying random forest. Just add this classifier ee.classifier.smile random forest. Okay, and number of trees 100. So we also use some other factor. It's called that hyperparameter optimization. Hyperparameter optimization. You can also apply to identify best number of trees. So this technique I already show you that how we can identify best number of trees when I discuss about the land use land cover classes. So in this case I simply apply the 100, but it's not the best. So how we can identify for the best number of trees, you can also apply. It also help you to improve your accuracy. So in this case I simply run my model based on the 100 number of trees. Okay, and then further simply train our model. And if you check, just simply print this classifier, just like copy, and I want to check some information, just apply the explain and run the code. So now I can get all of the information about that for this classification. Okay, it's working. Okay, show the one information class feature is missing. So let me check. I think some class property or some class feature is missing. This type of GT. Just a minute. I think some problem on the this type of training sample. I think some features are missing. So that's why it creates this type of problem. Property class of feature is missing. Okay, just a minute. But which one is missing? Okay, just let me run without, just only for the G2 and G3, and then check what happened. Cannot work. Okay, let me try for GT. Suppose. Oh, just let me open remove for GT3. Suppose one dataset have some problem. Suppose there is no feature of class. So that's why it show this type of problem. But when you take the data, so you try to put all of column, okay, for the class property. It still not work. Let me GT3. Or just keep only for the Just check now. This problem is in our data set. If you check the first, suppose this point, if you check, we find out the class is 1. Okay. So this is the level of this class. But for the GT2, this data set, I think it's not added the column of class. If you check this type of point, there is no class information. So that's why it creates this type of, there is no label, there is no property of class. So that's why it creates this type of problem. Okay, but you can see only for the first, you can check, click on the first, suppose this data, we find out the class. Okay, class is the 1. Then check it, suppose this is the another, if you check, we find out the class is the 1. But for this GT2, there is no class level, so that's why it create this type of problem. Okay, but when you take the data, you try to add all of class level, so you can see there is no column about the class information. So this class is 2. So further we simply create a column in our Excel file or CSV file to add the class 2. Okay, just simply put the 2. Then suppose class 3, suppose class 1 is very low, then class 2 is high, and class 3, GT3 is the very high flood occurrence. So you need to add, suppose I think GT3 is also not have this type of class, so that's why it create this type of problem. So if you check, run the code again, just add the GT3. So in this case, this GT, it's mainly your class, it's a 1. Okay, then GT2, so it's mainly class is 2, and GT3, this class is 3, okay. So basically this one, it's indicating about that very low. Suppose I just put here the low, then it's a high, and this it's a very high. Okay, very high. Very high. So now it's showing there is no class. So let me try to add the class property from here. Just you can click on here in this data set. Okay, so this is setting property. Click. So it show the flood level. Okay, it show the flood level. Okay, but I want to put all of those the class. Suppose just click on the setting properties and class 1. Okay, class 1 is okay, nice, there is no problem. Then GT2, if you check, just click on here, we are just setting the class 2. Okay, for that, and then put the GT3 is the class 3. Okay, then I hope it will work. Click on here and put the class, it's a 3. Okay, then we simply add the all of class, and for the non-flood we try to add the class 4. Okay, class 4 is the non-flood, so just I put the class, it's a 4. Okay, 4 is indicating about that there is no flood, non-flood study area. So we simply said add the all of class. Okay, suppose GT, this class is 0 1, so this is the 1, then this one is for class number 2. Okay, then this one is for class number 3, and this one is for 4. Okay, 4 number class indicating about the no flood. Okay, so we just create the total 4 class. And finally another, it's called that NF. Okay, this class number is 4. Okay, who is indicating about that non-flood area. Okay, so we just make this type of classification: low, high, very high, and non-flood area we try to identify. So now let's check, I hope it will be work. Let me check what happened. Just merge GT3 and also merge the NF. So now check what happened. Okay, great. So now it's properly worked. So first time we just make the mistake for our class level. Suppose some class property is missing, we find out. So then when I just add this type of class property, it will be very work there. Well, there's no, if you check this model, so in this model we are just input the total 4 class, 1 2 3 4. So 1 is the very low flood susceptibility, 2 is high flood susceptibility, 3 is very high flood susceptibility, and 4 is no flood. Okay, there is no flood. So we create total 4 class, 1 2 3 and 4 class we just create. And if you check the importance, so we can check, we just add the importance value for all of factors, and we are just applying the number of trees 100. This is the out back error estimate, and this is the trees, we create the 100 number of trees. So this is our data. Okay, and this is our data, we are just applying the random forest. So now this data we simply connect and make the prediction and make the classification. So for that I simply take a variable, suppose flood susceptibility, and call the predictors. Basically it is stored all of values, all of bands. Okay, all of bands is stored in here, just call it and use the classify function. Okay, classify function, and then call my model. So basically this classifier, it is stored my model, this variable is stored the model. And then if you want, you can also add the map. Suppose just I add the map, suppose map dot add layer of flood susceptibility, and then I add the color. Suppose mean, it will be start 1 and max 4. Okay, because basically this type of class we just generate 1 2 3 4, total 4 class. Okay, so simply add the color for different 4 class, just add the color plated. Suppose I put the very low flood susceptibility, use the this color and we add. Suppose I put here yellow color. Okay, or you can use the different types of color. Suppose then very low, then high, I just use the high for this color, suppose pink color. Then very high, I put this type of blue color. Okay, it's indicating about the very high flood. And for the non-flood, another class I want to add, suppose this color I want to add. Suppose green color. Okay. So suppose yellow, pink, blue, and green. Green is the non-flood region. Yellow is the very low or low flood susceptibility. Then high flood susceptibility and very high flood susceptibility is the blue we are just add. And add the layer name. Suppose flood prone areas. So now run the code and check the result what happened. And it's the clip with a steady area which is table, and run the code. So now if you check, we find out this type of mapping. Final output we find out. So this type of blue color indicating about the very high flood prone area. Okay. This type of green color is the non-flood prone area. Okay. And then pink color, if you check, we also find out some yellow color, some place. Okay, some it's the pink color we find out. So we just create this type of classes. Okay. Low, then yellow, pink, blue, and green. So basically we find out that pink, then blue and green. Suppose low, very high, and non-flood region. So we find out this type of place is the non-flood region, and this type of place is the very high flood prone area, and this type is the low flood prone area. We find out this type of place. Okay, and now what the accuracy of our model? So we need to check the accuracy for this flood susceptibility mapping. So for that we are just applying the validation. Okay, validation data set is simply called. So just we use the sample regions and create the validation using the 30% data. Okay, because 70% that we are just used for train our model, and testing data set is stored that 30% data. Okay, for checking the validation, and then class it's our property name, and then geometry, just simply check the validation. So now run the code. So now we find out the validation sample size for our model. We found out that this is the total sample size. Okay, for validation, and from here we are just make the compute the error matrix. So just apply the dot error matrix. Or we can also check the validation using the another way. Suppose, so take a variable, suppose confusion matrix, and apply ee dot confusion matrix, ee dot confusion matrix, and then call the testing data and connect with the model. So here I already do it using the validation, just I copy and paste here, and from the validation we simply calculate the error matrix. In this error matrix we need to add the two value, mainly actual value and prediction value. So actual value basically it's a class, And prediction value, if you check, this is the prediction we can get from here. So just print this susceptibility, this variable, then you can find out that prediction band. Okay, so just let me do it and check the result. What is the prediction band? Just print. So now if you check the band name is the classification. This is our prediction band. Okay, just take copy the classification and then connect. I put here, just paste here. So this is my error matrix. We simply compute the actual value and prediction. So then further just print this confusion matrix table, and from we are just use this confusion matrix table and make the accuracy, overall accuracy, cup accuracy, or producer accuracy, or consumer accuracy. We simply compute from this confusion matrix table. That is the problem. It's a problem is that okay, so let me check the testing data. Testing. These are testing data set, yeah. Just like copy. Let me try to this. So validation from the error matrix, actual value and prediction value. Just compute. So I think some empty data set we also find out, because some data set there is no value. So that's why it creates this type of problem. So now we simply set the validation size greater than 0. Okay. So it helps you to guard against the empty test data set. So now I hope it will work. So we find out this type of phonetic table. So if you check, we find out. So now from this matrix table, you can compute suppose accuracy. So just print all this error matrix and apply the accuracy function to compute the overall accuracy of this model. Or we are just use these things. we find out this type of accuracy, 97% accuracy of this model. And further, you can also export. Just use the same line of code, export image to drive, to exporting this susceptibility classification map, help of machine learning. So from the text, we can easily download this data. Okay, subsequently simply download, just run, and then further you can also make the map using the ArcMap. And for your research paper, you must need all of vector. We need to download, and you just can also follow the different types of paper, not only for that. So flood susceptibility or assessment using the different machine learning. So in this time they are used at that machine learning and also multi-criteria decision analysis. So if you want, you can also do it. Suppose let me show you the another port. So how we can easily identify for flood susceptibility, help of ASP method, analytical hierarchical method we also use. But machine learning, just apply this process and then we can easily get the result. Okay, anyone any question about that? You can ask me please for the machine learning method. Okay, yes, please.
Yeah, thank you. Getting this data set, where we find it difficult to get a ground truth data, can we get most of them from the satellite imagery?
Yes, so it is possible. Suppose frequency ratio. Okay, so we are
So like
also use
precipitation.
the frequency ratio, mainly FR. So this frequency ratio, we can also identify, suppose flood, suppose where is the high flood, low flood, or non-flood region. So this type of things we can identify. Okay, not need for the ground, not need to visit. So we can simply use the suppose a frequency histogram or frequency ratio. This you can see basically they are the lot of way. Suppose one way is that machine learning, then multi-criteria decision model, or also artificial intelligence or logistic regression or frequency ratio. So this frequency ratio, these things all help you to get the frequency, okay, for the flood. Suppose I find out the some place lot of times, so every year we find out the flood for this place. So it means that it's very high flood prone areas. Suppose some place I find out the not every month, but sometime I find out the flood. So it's just so suppose low flood prone area. So when you take the flood prone point or training sample, we can just apply the frequency. Okay, suppose in this code, his code I show you that. So in this code, we also use the frequency histogram, suppose FR, and then we collect this type of place. Non-flood we can easily collect from the ground, no problem. Take the training sample. Okay, so we can easily collect, suppose this type of red color, we find out that every month we find out the, or every season we find out this type of place have the flood, this type of red color. Okay, then suppose this type of green color, not every month, but after 2 months or some season. So then we just use it another, okay, label. But this type of red color, we find out that every month or every year we find out the flood, this type of place, red color, this type of training sample we find out. But this type of green color, not for every month. Suppose it's the low flood susceptibility, this type of red color is the high flood susceptibility, and this type of place we can easily identify it's a northern flood susceptibility, we can easily identify. Okay, so further we are just applying the flood frequency ratio, and this thing we can also identify for the different way. So we can also use the, suppose you just identify, suppose you can, suppose 10 years data you can simply take. Suppose in the 10 years, suppose you simply change, suppose from 2010 to 2020. Suppose this 10 years you just make a it's called the tally. We can just apply the tally. Suppose 2010 to 2020, we can simply apply, suppose different types of methods. Suppose we can easily apply NDWI. Okay, NDWI we can simply apply. Okay, or we can also apply the, suppose flood mapping. Okay, we already know about that sentinel SAR data. We can also use and identify flood area. Okay, you can also identify using the sentinel SAR data. So you can simply, suppose 2010 to 2020, every year you try to identify flood map, we can simply create. Suppose in NWI you can easily apply using the land set. Okay, using the land set we can easily get the land set imagery we can easily get. But for Sentinel SAR data, it's available from 2015 or 17. Okay, then it also help you to identify flood area. So you can simply apply this type of land set or Sentinel SAR data to identify flood prone area for your study. Okay, and then check. Suppose 2010 and 2020, where you find out that high flood. Okay, so this type of point you can simply use. Suppose level, you set the level, so it's a very high flood. So then you can simply check. Suppose I find out that, just simply create a histogram or calculate the frequency of flood. Okay, for between this suppose 10 years data or 5 years data. Okay, and then just create the frequency ratio or tally. Okay, suppose for this place I find out the 10 years, every years I find out the flood for this type of place. Or for this type of red color, suppose every years I find out the flood this type of place. Suppose for this type of place I find out the flood for the 2 years or 3 years, so it's not the high flood region. But this type of red color, suppose between 2010 to 2020, when I make the flood mapping, suppose using the NWI help of Landsat data or Sentinel-1 SAR data, I find out this type of place, I find out the flood every year. So this type of place is very high flood region or very high flood prone area, I consider. Then suppose green color, so suppose every month I don't find, but after 2 months 3 months I find out, so it's a low flood. Okay, suppose this type of place there is no flood, or anytime there is no flood happened, so it's a non-flood. So when you take the data, just apply this type of technique. Suppose just simply create the frequency. Suppose 2010 to 2020 we find out where I find out the flood. Okay, suppose this type of place every time I find out the flood, this type of point, so we just consider it's a very high flood region, this type of point. And this type of place not every month or not every year we find out the flood after 2 years or 3 years, so it's a not high flood, it's a low flood prone area. And this type of place there is no flood, so simply use this type of technique. Suppose a 10 years data or 5 years data, and then create the training sample. Okay, yeah, help of frequency histogram. Suppose you can check here, I just take the data gt2 and gt3. Suppose for the 10 years I find out this type of place have the low flood prone area, so I find out the low flood this type of place. Then gt2 I find out the high, and gt3 it's find the very high. Suppose for the 10 years every year I find out this type of place is the flood area, I find out this type of place. So just apply this type of things and take the training sample for, and then further just apply the app machine learning and identify the flood prone areas. Okay, so this is the way. Yes, any question please?
Yeah, in presenting the findings, can we generate graphs or charts to show in time and space where there is much more flooding and where there is less?
Which one?
Yeah, because sometimes when you are presenting this, they will ask you to present charts or graphs, like to show in space where these things are changing with time.
Okay, so for the flood, so for that we need to apply the Sentinel-1 SAR data. Suppose, okay, let me show you the another code, then you can get the idea. So this code I already share in our 7 days online training program, how we can identify flood area, help of Sentinel SAR data, Sentinel-1 SAR data. So this code we can simply apply to identify for the flood prone area every year. Suppose I want to identify 2015 to 2025. Okay, these 10 years I want to identify for the flood frequency histogram, I want to identify for every year, and then check what happened. Okay, so for that we can simply apply. Suppose let me show you that flood mapping, help of SAR imagery. So this code we already know about that. So this is the one of, so this is the year, suppose 2022. Okay, suppose for this area where is the flood we can easily identify. Okay, help of 2000 help of SAR imagery. Okay, suppose this type of place I find out that flood area. So then this same code you also use for 2021 or 19, 18, 17, and then check. Okay, and take the training sample. Suppose you can say this type of red color indicating about the flood inundation area. Okay, in 2022. Then let's check what happened for the 2021 or 2020. Okay, so every month we simply add some training sample. Okay, suppose for it's called the flood frequency. Okay, this type of place. Suppose now let's check 2021 or 2020, 19, 18, 17, 15, and then check this type of place. We find out the same flood or not. Okay, so then we just simply take the training sample. Okay, using the, but it show the, this code mainly show you the flood inundation mapping. Okay, but this code show you the flood susceptibility or hazard, flood hazard mapping, help of machine learning. Okay, for the machine learning we need the training sample, and this training sample we need to collect from this code. Okay, from this code we need to collect the training sample. Suppose I find out this type of place is the flood in 2022. So now let's check what happened for the 2021. Let's check what happened for 2020, then 19, 17. Just take the 10 years data or 5 years data and then identify for a frequency. Okay, which place have the more flood, which place have the low flood, and which place is the very low flood, and which place there is no flood. So then identify this type of training sample. Suppose in this case you can easily take it. Suppose click on here. Suppose in 2021. So this is the map 2022. Okay, this is the result. So you can simply find out this type of place. We find out the flood. Okay, suppose take the training sample from here. It's a flood area or it's a flood area. So now for this same place you try to check what happened for the 2021. Suppose simply check the 2021. I just simply put the, I simply change the year. Suppose 2021, same season. Suppose 2021. So now let's check what happened. So for this same place I find out the high flood or not. Okay, so let's check. Just it open the map. Now this result we find out the in year of 2021. So you can see we don't find out the flood, okay, for this type of place. So now in 2021 I find out this type of place is the flood. So you take the another training sample. Suppose now let's check. Suppose we find out this type of place is the flood. So now you just apply this process. Suppose for every year. So every year, suppose I just check for the 10 years, and 10 years I find out this place have the flood. This place I find out the flood. So this is the high flood prone area. We just consider when I use the machine learning. So I just use this training sample as the high flood prone areas. I just use it. Okay. So this is the way. So now let's check for the 2021 or 20, 19, 17, and then check which place we find out that high, and then further simply export it as a shape file, okay, or CSV file, and further we can simply add, just upload in the Google asset. So in this case we simply upload the Google asset, and then you can GT, GT2, GT3. Suppose very low flood prone area, then high and very high, and NF is the not flood. We take this step and then make the class. So this class is the 1, then 2, then 3, and 4, and then we further simply make the classification for the total 4 class. Okay, and for this code I also send you the both of code. So this code help you to identify for the flood areas or flood inundation. So from the inundation you can take the training sample. Suppose very high frequency of flood area, then low, then very low, and then not flood. So just we take the training sample, use the frequency histogram between the 10 years or 5 years. Okay, then we check for this place every month will be flood happen or not. Then take the training sample, and further this type of training sample simply use in our model. Okay. Okay, any question? Ask me please.
Okay, so we download those training samples and similar to point and code it, then we can now upload it in the Google Ads engine, right?
Yes. So just we are use this code to get that data. Suppose you can apply this code for the 10 years. In the 10 years, which place you find out the maximum time or maximum year I find out the flood, which place. So you just take this type of training sample, and this type of training sample indicating about the high flood prone areas. This type of training sample where I find out the maximum year or maximum time I find out the flood. Okay, and then we are just use it for.
Okay.
Okay. Okay. So I hope you also get the idea how it will be work for that flood prone area. And same like as for landslide. Okay, so landslide is also another factor. So landslide, basically we can easily identify for landslide hazard area. Okay, help of machine learning also. But for that we also need the same process. So we also find out some data source from the different website. Suppose frequency histogram of Landsat data, frequency data for the landslide. Okay, so when you work with the landslide, okay, let me show you the some code, then get the idea. So let me just run it. And if you simply search some paper, so this is the landslide, you also try to read some other paper also, then we find out the load material idea. And we also try to, because we also have the long-term basically lifetime teaching support. So regarding this type of paper, when you work or when you try to publish, suppose flood susceptibility using the machine learning, or landslide susceptibility, or also agricultural land suitability, and not only for that, any topic which I including in our syllabus. So all of topic we try to publish the scientific paper. Okay, so this type of topic is very important. Every topic we are just use, and we can easily publish the different types of scientific paper, okay, for the different way. Okay, so for the we have just long-term relation to publish this type of scientific paper for every topic. Suppose flood susceptibility, agricultural land suitability, or deforestation, for forest monitoring, then drought monitoring. So different types of paper we can easily use this type of topic and publish, or soil salinity. Okay, so it's very important, then you can easily get the idea. Or land use land cover prediction. So this is our last topic. So for the land use land cover prediction, I can also try to show you that, then you easily get the idea. So now we talk about that another topic, which is landslide. So if you simply search, and you also try to read this type of paper to get the more better idea about the flood susceptibility. So I simply search here, suppose landslide susceptibility machine learning. So simply search. So now you find out different types of paper you would check landslide susceptibility using the machine learning, literature review, machine learning method for landslide susceptibility studies. Also again the comprehensive slide, landslide susceptibility using the support vector machine algorithm, landslide susceptibility machine learning. Okay, then evaluating the machine learning and statistical prediction technique for the landslide modeling using GIS based machine learning. So let me open it. So this is the one kind of paper that use the random forest model, logistic model tree, or RBF classifier. Just a minute. The hybrid machine learning approach for the landslide susceptibility modeling. So landslide inventory data we need. Okay, so basically when you work with the landslide, so we need the ground truth data. So in this time you can see this paper use the Google Earth image, basically Google Earth Pro. So we can easily identify from the Google Earth Pro, we can easily get basically, because Google Earth Pro is very high resolution, or Google Earth image, it provides the high resolution. So from the high resolution you can easily take the training sample. Suppose landslide training sample, so it take the 170, okay, from the Google Earth engine image, and air photo check the against the available historical record. Okay, so they are use this type of things to get the data. So you can see, so this landslide image. So we can easily open the Google Earth Pro or Google Earth image to visualize, and this type of things we are just use the training sample. Okay, just use and take the training sample for the landslide area training point. In this paper they also take this type of point, and they are also use the total 12 factors they are using here. Suppose they use the slope is one kind of factor, aspect, then elevation, then curvature, then also slope length, then valley depth, distance to river, distance to road, distance to falls, topographic wetness index, then train roughness index. Okay, for landslide analysis and modeling they are also use this type of things, as well as also use the frequency ratio method. Okay, landslide pixel per percentage of the number of classification. This is the study area. They are used here. You can see all of factor. Okay, just create this type of factor and make the map using the ArcMap software. Okay, to display the research paper. Okay, to display the research paper, they use this type of map. So indicating about that elevation curvature, and also this is the paper. You also try to read, then you can easily get the more better idea how it will be worked for this type of factor, how to relate to the landslide or a lithology, then distance to fall, distance to road, topographic wetness index, or train roughness index. So this type of things simply add, and they are apply here. You can see in this time. This is the another model they are also apply. ANFIS model they are also applying here, but we are applying the machine learning. And if you check landslide susceptibility mapping, this is the flow chart. You can see they are used at the this type of factors which influence the landslide. Okay, and they are also used at the different types of model. You can see RF random forest, okay, artificial neural network, okay, also PSO. So different types of model they are compared their result using this type of model, and finally check the accuracy using the root mean square error, or create the final map landslide mapping they are also using here. And you can see they also add for the different method they also use the different types of maps. So this is the RF FB FDT model for this model. This is another model map. Okay, so they are used, and they also calculate the area. Suppose for this is model, suppose for this model how much area we find out. Okay, then landslide classes, okay, very high, low. They also compare this distribution of the classes on the susceptibility maps using the different types of model. So it's one kind of paper for the landslide or machine learning feature selection for the landslide susceptibility mapping. Mhm. So let's try to show you the one example, then get the better idea how to apply. So in this case, first of all, if you check the study area, just add the layer. So this is my study area, AOI. So this is study area. So basically in the hilly region, you find out that landslide. So this is study area. Okay, this same we are just use the DEM data, NASA SRTM DEM, and click with the study and call the dem and run the code. So this is the dem. If you want, you can also add the color to visualize the dem. Same process. Suppose I add the color. Low elevation, show this type of blue color. Then get it, then use this type of yellow color. And high elevation, show this type of red color. Just apply. And then import. So copy this visualization parameter and paste after the object name, and it's a dem. So dem already simply find out from the NASA SRTM, and you can identify where is the high elevation, where is the low elevation, easily find out this type of data. And from the dem we simply compute the slope or elevation. Dem mainly elevation. Okay, so from the dem data you also set the elevation and compute the curvature. Okay, so this is the function. So from the elevation, you simply compute the convolve, and e.kernel Laplacian function is simply used to create the curvature. So just add the layer of curvature for this study area. Just copy and run the code. So now it's added the curvature layer for this study area. So you find out this type of curvature. If you want, you can also add here the color to look more beautiful. It's optional. If you want, you can also add or not. No problem. So what's stressing? Just put 98%. And further, just add the color. Suppose low, greater than this type of green, greater than yellow, and a high, show this type of red. And now apply. So now we find out this type of curvature. Just import this parameter, just copy, and we simply add the layer of curvature from the dem. And now it will also display the same. So I already displayed. So then aspect is very important. Mainly aspect is the follow-up direction. So just I call e.train aspect, and I want to compute the aspect from the dem. So simply add the aspect layer. So now run the code. For this study, we find out the aspect. So this is the aspect we find out. Okay, aspect layer. Then slope. Okay, same. Just we simply add the slope. Then run the code. So now we add the slope for this study area. Okay, so this type of identify about the high slope. You can also add the color, but it's optional. So in this time I simply write the code. Then rainfall is very important. Okay, so I simply add the rainfall charts data. But if you have the meteorological data, it will be more better, because charts data it's provide the 5,000 okay pixel size. So that's why we find out some problem on the map for the displaying the rainfall or precipitation. Okay, you can see, find out this type of grid.cell. Okay, because this pixel size is 5,000, but when you work with the station data, okay, then it will be more better. But it also work, no problem, because some place we don't have the station, then we try to use the chart satellite data. Then also compute the NDVI, okay, mainly greenness. So in this case, I simply apply the Landsat 8 imagery and filter it for the specific year. I take the less than 1% cloud cover and make the median. And further, we simply take the near infrared band, short wave infrared band, and then compute the NDVI. I think for the near infrared band, it will be for NDVI. We just apply the red. Red is for B4, and near infrared band is B5. Okay, for Landsat satellite data, B4 and B5, and it just simply call the B5 and B4, and now add the NDVI map just on the code. So now it's added the another layer, create the NDVI, normalized difference vegetation index, and this index we can compute from the Landsat 8 satellite data. So you can find out this type of map. If you want, you can also add the color. Suppose just add the color to identify the vegetation. Stressing 98% I keep. So this is the vegetation. Green about the high vegetation area. This type of green color. Okay. Just I copy the visualization and connect with the layer to display. Where is it? This one. Just copy the visualization and then connect after the layer name. So now it's connected. As well as we also add the land use land cover mapping. So just run the code. So here I already make the land use land cover for this study area. So you can also add the color for different types of land use land cover classes. Then it will be look more better. So I just put the optional. And further, so okay, so hillshade you can also visualize. Again, suppose hillshade view of your layer and the hillshade view map. Just run the code. So we find out this type of hillshade view layer look like that. Yeah. And then simply okay, drainage density. So I already add the drainage density for my study area. So now it's added another layer of the drainage density. We find out this type of place is the high density. You can also add the color to display the more better. So this is the drainage density. So this type of layer we need to create using the ArcMap or QGIS software. From the drainage line, we can get a lot of tutorial about that, how to work, create the drainage density is available. So just simply create this type of drainage density as and then save the file as a GeoTIFF file. Okay. So this GeoTIFF file simply import in the asset tab and further just open and display. We find out this type of drainage density map. Okay. Then distance from road, same. Suppose you can simply get the road shape file. Okay, we find out the some road. So then simply compute the Euclidean distance. Okay, and create the distance from road map. So now run the code. So now it's added the another layer, distance from road area. We also find out. So we find out this type of map for the distance from. But if you want, you can also add the color to identify. And then also soil data. Just add the soil information. So you can find out this type of soil. So soil class is soil type. Okay, so you find out this type of soil type information. And then, okay, so now we need to identify slide and non-slide area. So for the slide area, suppose if I show you the layer, so I will just add the map dot add layer, and then call this layer slide, and I'm going to add the color. Suppose this is my point. Okay, it's indicating about the slide area. So this type of place I find out the slide, landslide. So now run the code. So now we add some training point or training samples. So you can see we find out this type of training sample. So it's the landslide training sample. So this type of place I find out the landslide. This type of red color indicating about that landslide. But now there is not the histogram, there is not the frequency. Suppose when you apply the frequency, we need the frequency data. Suppose very high landslide, then very low, then low. So this type of data is just show the free slide area. So this type of place I find the slide, and I have the another data, it's the non-slide data. Suppose if I show you the data, another layer, so it's another class. Suppose map data layer, okay, this name is that non-slide. Suppose just I put the another color, I put the color is suppose yellow. So this yellow, this type of point, it's that non-slide area. So now run the, so again we find out this type of two class, suppose slide and non-slide. Okay, but in this case we also add the more other information. Suppose frequency of slide. So suppose this type of yellow color, suppose this place I find out that 10 times I find out the slide or slide area 10 times. So then I consider it's a very high landslide area. So this type of place I find out the 3 times or 4 times, then I put, suppose it's not very high, it's a high or low slide area. Okay, so that it's called the frequency. But in this time this data set have not the frequency, we are just have this type of point if the landslide. But when you work with the more details, suppose I want to identify different types of landslide for an area, suppose very high, low. So then I need the total 3 categories data. Okay, suppose very high, then very low, then low slide for an area. I need the 3 categories data or 3 frequency data. But in this time we have just the data slide and non-slide. Suppose this type of place I find out the slide. Okay, but how much time? So this type of information is not have this type of data. But when you work, so you also try to identify this type of information. Suppose for this type of place, how many times I find out the slide? Suppose 10 times. So here I find out the 10 times, I consider it's a very high slide area. Suppose here I find out the 5 times, I consider it's a high. Suppose I find out the 2 times or 3 times, I consider it's a low slide area. So then we are just make the different types of classes. But in this time I have the data only for the 2 datas, suppose slide and non-slide. But when I use this data, I can generate the 2 class, only 2 class. Suppose I can easily identify slide area, okay, and also identify non-slide area. But when you have the frequency, suppose this point I find out the 10 times of slide, so I consider it's a very high. Suppose this point I find out it's a 5 times, So I consider it's a high. So at this point I find out the 2 times of slide. So I consider it's a low. So then we can create the different types of classes. But now there have only 2 class, slide and non-slide. So when I use this data set, I can just use only for the 2 class I can create for the slide area and non-slide area. Help of machine learning. So let's go try to discuss. So this type of training sample I have, and I already create all of factor, okay, for the landslide. So now we need to combine all the variables to into a single image. So then just take a data set, I take a variable, and in this variable, if you check, I just apply ee.image.cat, and I simply call all of variable: elevation, curvature, aspect, slope, rainfall, ndvi, then LULC, then hillshade, then drainage density, distance from road, and soil. Okay, so this is my all of factor. Okay, so all of factor just I combine and store it in one variable data set. So now I just set a level. Suppose I put the level is the class. So suppose in this time only for the 2 class, 0 and 1. Suppose 0 is the slide, 1 is the non-slide. Okay, and I just use this type of bands. So this type of bands is my for prediction bands I also use, and I simply input this type of this data set, select with this band. So I want to extract all of information for my this type of training sample. Okay, elevation, aspect, slope, precipitation, ndvi, okay, hillshade, so all of information. So now further we simply apply the train our simply extract the values. Okay, so and then print the information, then you check, just run the code. But it will be more better when you add the frequency. Okay, and from the frequency we can generate high, very high, and low. Okay, then we can easily make the more better classification. But in this case, if you check, this data set have only for the 2 class, only for the 2 class. If you check, the class is that if 0. Okay, and for this point we find out the aspect below, then this elevation, then hillshade, nd, precipitation, slope. So class 0 and 1 we find out only for the 0 and 1. 0 and 1. Okay, so all of class we find out only for the 2 class, and further we just train our model. Okay, so random column we just simply spill the data, train set and test set. Okay, same like as land use land cover classification, and we create the random forest model to identify this result. And in this case we are applying the support vector machine, okay, svm classifier, and we are just input, because in the 2 class mainly binary class, slide and non-slide. For the binary classification we find out the more better result when you apply the support vector machine algorithm. So just simply apply the support vector machine algorithm and classify the layer, and we easily identify. So let's check the final result. So now it display only for the 2 class. So we find out this type of class. Okay, so we find out this type of red color is the slide high slide front area, this type of red color, and this type of green color is not high front area. Okay, so we find out this type of red color is the very high slide area. Okay, and this type of green color is not high or low. Okay, so basically we find out the 2 class. But when we add the more data, more frequency data, so in this we are just make the model help of these 2 data. Okay, slide and non-slide. So now we find out this type of classification, this type of red color indicating about the high slide prone area, and this type of green color is the not high slide front area. Okay, but when you work with the real project, we try to add the frequency to identify more class. Suppose very low, high, very high, then it will be more better. And further simply check the accuracy of this model. Okay, just apply the confusion matrix table and add the error matrix. From the error matrix identify actual value and prediction value, and calculate the confusion matrix. Just print all of this and check the result. So we find out this type of accuracy. If you check, this is 75% accuracy, overall accuracy. Okay, so in this case, why we find out the low accuracy? Because in this time we are just make the classification only for the two class. Okay, but when you add the more class, suppose very high, then low, very low, this type of data, then when you integrate, then this accuracy is also high, we find out. Okay, and further simply export the result as a GeoTIFF file format, and also it also exported that also shape file or training sample. Okay, but this is the way. But when you work with the real project, then we try to add the frequency. Suppose how many time I find out the landslide for a specific point. Suppose I find out the 10 times, then I just use it as a very high slide area. Okay, then I suppose some place I find out the 5 times or 2 times, then I just make the distribution, this type of points, and make the classification. Just apply the same process, but we need to add the more classes to identify more better result. Okay, any question please? Okay, anyone any question? Ask me about that.
This one will check the codes. Sometimes when you check the codes to the real life, then you can now see the things that you need to add to the paper.
Okay, so for that we simply check the Google Earth images. Okay. Google Earth image, and you can also check the Google Earth Pro. Okay, because Google Earth Pro, we can also identify for historical data. If you check the Google Earth Pro, suppose let me show you that. Simply open the Google Earth Pro. So it also available on the desktop version is more better. You try to download the desktop version, and then we can easily identify historical imagery, high resolution imagery. So from the high resolution imagery, we can easily get this type of point. You can easily identify. So you also try to download the desktop version. So okay, just a minute. Let me show you from the web version of Google Earth. Or okay, just let me show you my another device. I think it's not. So let me share just a minute. So you can easily check. Just download the web version of desktop version, okay, of Google Earth Pro, and from here you can easily get the high resolution imagery. You can also import your KML file or KMZ file in this layer, and then simply open your study area. We can get this opportunity only for the desktop version. I think web version is not available. So you also try to download this data. This software, simply download. So you can see it's very high resolution, you find out. And it show the time. You can see, find out this is the imagery data. Okay, it show the result 2024. Okay, and you can set the latitude, longitude. So when you just remove your cursor, you find out the latitude, longitude, and also get the elevation. You can see the 91 feet elevation. Okay, and this is the imagery data. So when you just move it, it also change. We find out the very high resolution imagery. So now we can easily change the image date. So it's for the 2024, but I need to check the another years. So for that, you can see the another option in here. You can see the time. So you can simply click on the time. So now I can check suppose another year. So you can see just click. So now it show the result 2020. Okay. High resolution imagery find out. Just click on here. So it show the 2017. Click on here. Then we find out the image 2014. Then we find out, click on here, then we find out that 2013 what's happened for this area. So you can simply open a place, suppose any historic any place where you already know about that slide. So just open this slide area and try to check for the different year what's happened for it, for it's a slide or not. So you can see this is the image for 2004, and we find out the last image in 1985. Okay, just drag. So this is the image for 1985, but maximum probably we find out that or high resolution imagery. So I simply search here. Simply search. So I simply search this place. Oh, this is the one kind of hilly district. So we experience had a lot of time for landslide. And this is the image. It show the image in year of 1985. So let me check for this year 2012. So in the 2012 we find out this type of imagery. I need to check. This is the result for 2012. It's a 2012 image. So now I'm going to check for, this is the image for 2014. Okay, this is the image for 2016. This image 2018. This is the image 2020. This is the image for 2021. And finally we find out the image for 2024. We find out this type of scenario. So this is the very better place we can easily identify for historical imagery, very high resolution, and from here we can easily get the landslide information also for the landslide, and you can get the data. So different imagery, suppose every time I find out the landslide for this place, so then I consider it's a very high landslide for an area. Okay, then I just use the point, and you can also easily create, you can see, just click on here and we can easily create the training sample. Suppose this is my place, this place I find out the very high, so you can simply put the name. Suppose I just put the name is a slide area, or you can put any name. Okay, and you can also note the latitude longitude value. Suppose this is the slide area, I simply put, and you can add the some description about that, okay, in the below, and put the description. So different types of you can add, and then okay, so then it create the one point. Okay, you can see it create this point in here. Okay, so you can simply add that this type of training sample. Okay, not only for the one, you can take the more, and it also help you to identify or also training sample for the different types of prop. Okay, we can also just use this type of things, and then we can take the training. So just I click the another one, just click, then I drag it for my specific place. Suppose this is the another, just I put, and I put this the another point for slide. Okay, so I put, show you the manually. Suppose you can put the name, it's a slide area, suppose slides, and put the information, some information, simply add the below, and then okay. So now it create the another training sample. So just simply click on here and take the point. So it's the water body or others, and put the name. of this training sample. Water, and then simply add some information about that, and then okay. So now we take the training sample for the water. So this type of point further we simply export as a shape file or KML file or KMZ file. So then we are just use this type of point in our Google Earth engine, or we can also use for other point as a point shape file, okay, to extract the pixel value. So for that, just click the file and you can see the option it's a import option. Basically is just import our KML file or KMZ file. If you have any file, you can also import, but I want to download this type of data. You just right click and see the direction, snap view, properties, add. No, we can also take the different types of polygon also. You can see the polygon sample possible, but I want to export it as a KML file or KMZ file. How I can export? Make sure the properties, and you can also edit from the properties. Suppose just drag and put another place and add the name and export. So for view, open, save email, view in Google Maps, print, import, server, sign out, exist, then edit. You find out the copy properties, delete, then view, toolbars, different GPS location, movie marker, and add help. It's a print email, save emails, view in Google Maps, Google Earth Web. You had the save option. So at this point, I want to export save places. Yes, yeah, I find out. Yeah, save places. Suppose just click on the save places. Suppose then simply just I want to save it in the download folder. I put the name save area and then save it. So now it will be saved. Okay, this area is the save. So further, how I can open and how I can convert it as a shape file. So now it's a KMZ file. Okay, if you check the file, we find out the file as it's a KMZ file. But when I work with the Google Earth engine or when I work with the ArcMap, I need the shape file. Okay, so for the shape file, you simply open the file in the QGIS software. Because QGIS software, we can easily open the KMZ or KML file. We can easily open. Okay, so from the KMZ KML, you can simply convert into shape file. Okay, then this shape file simply open or import in the Google Earth engine easily. So let me show you this process also. This is just open the QGIS software and further just open this KML file. So it's saved in the download folder. So let me open. Click on the download. So you can see the slide area. Put the file name slide area. So this file simply drag and open the QGIS. Just paste here and then add the layers. So you find out, you can see it show this type of points. So you can see we find out this is the file. So this file is a KMZ file. Okay, this KMZ file we need to convert into shapefile. So very easy. Just click on here, right click on this layer, and you can see the save feature as. Okay, click on here, and from here you can see the history shapefile. Okay, simply choose the history shapefile, and I want to save it for a specific folder. Suppose I put the folder in the shapefile. I put the name. Suppose slide point. Okay, then save, and again it save it, and then keep others same, just okay. So now you can see it will be saved, and I find out it's a point shapefile. Okay, so you can also compare the result with the, just add the base map. Suppose just add the base map from Google satellite. I just add, and then keep it displays. But why it show this type of things? Okay, let me add suppose another base map, or Google Maps I try to add. Zoom to layers. Okay, why it's not showing the image? I think some networking issue why it's not load. Okay, we try to add the later. It's not the mandatory. So if you check the file, where is it saved? So I save it in this folder. So you can see find out this all of folder SSP, PRJ, DBF, SS. So you can simply select this type of file and then import in the Google Earth engine easily. So this is the way. So just simply take the training sample, okay, from here, and then you can simply use it in your, just simply download the KML file. Okay, so just click, and you can see the save place as this option, and save it as a KML or KMZ. Both files are supported. So simply select the anyone and put the name and save it. Then it will be saved as a KML or KMZ. And this file simply open the QGIS and then save it, convert as a feature collection. Okay, point shape file. So you can also use the same process to digitize any area or any training sample. You can also create the polygon. So it show the point. So you can create the polygon. Suppose you just create the polygon, this type of polygon you can also create, and also just convert as a shapefile from the KML or KMZ. Okay, any question you can ask me. And from this Google Earth Pro, you can easily get the historical data, basically different types of very past year. You can easily find out the very high resolution. So from here, you simply extract the data for the slide or non-slide information. Okay, anyone any question? You can ask me, please. Okay, so now we talk about the problem solving class and agricultural land suitability analysis. We try to discuss in the next class, inshallah. Then you can get the more better idea. So now kindly share me your problem and show me that, please. For the previous classes, any problem, simply share the screen and show me. Yes, please.
Yeah.
It's opening. Yes.
Yeah, this was it. Initially, we ran all these codes.
Yeah.
We ran all these codes, and it was showing a negative correlation. Sometimes when I ran it again, it's now showing a positive correlation.
So basically for the NDVI and LST, we find out that negative correlation. Yeah.
Yes, yes, that's what initially. So I don't know what happened along the line when I ran it again. After some time, but it's taking some time for me to read my slides here.
Okay, but it show that your positive
becomes,
correlation.
Yes, yes. So I share with you the code. That was one. The other problem is he commented on the figures. We need to find ways to create like the coefficients of correlation where we use 80%. The figures we show up here. When we download it from Google Earth Engine, the images are not clear.
Okay, so did you use the, okay, can you show me the export code? It will be more better. Mainly export code, export image to drive. Sometimes export image to drive, if you are use the scale value is very high, then it will be create the enlarged pixel, or you can also use the max pixel, then it also create the enlarged pixel. Okay, then we find out the not very much good map. It show the some enlarged pixel map.
Okay, so this was supposed to be actually negative, not positive.
Yes, yes. Okay, so so is there any cloud or what's the happen? Just can you show me the map? Okay, for the NDVI, NDVI and LST map. And it show the result from 2000 to 2020, yeah, for 10 years or how many years?
Yeah. Just finding ways where I save them to you. How can I show the GIS, the one that's in the ARC map?
Okay.
I think I need to go to Windows. I can show you.
Okay.
Do you see this?
Yes, I can see.
Yeah, so this is the process version. You can see that these are the images. These ones. So these are the. But I wanted to show you the one in the ARC map itself.
Okay.
Let me see how I can.
Yeah, just open.
Is it Windows? I cannot see my ARC. Where is this? So you see, this is the
yes.
So this is the ARC map version. You can see I've generated. I just don't know how I can show you all of them. All of them are in here. So the ones that I dissolved are here. The ones, the polygons.
Yeah.
So this is the kind of image that I generated. But he says they are not. We need to have something very much sharp. So I don't know how I can interchange this.
So which year is it?
I just don't know how to show you the different ones because I don't know if it will take the full time to read or not. They are all here. I wanted to show the different ones. And then I'm using a cracked version of Acrobat. I can share it online. But I don't know how I can't click on my own versions to show you here.
Okay, click on the map, click on the view, click on the top. You can see the file edit view option. So click on the view.
There is no view here. I can just see full screen and stop sharing.
In the top right, left side on the arc map, yeah, view. You can see the view option. File, edit, view, then bookmarks, then insert, then selection, geoprocessing.
This can't, is what I can't click on. I can only see this.
And view, click on
But
the
anyway, instead
map
of
view.
this time, I will probably need to download and share them with you and see how we can look at it. So it show full screen video. It's not allowing me.
So your screen is freezing, not showing properly.
Yeah, so probably let me download and share them with you and see how we can work with it, because I don't know how to present it properly.
Okay.
It should be like visual search. It's not working. So that is the point. So these ones, I will, for this other one, I will share the code. Then we can see why it is negative, why is it positive when it should be positive.
Okay, again, I can share this code also. I'll try to check it why it show the positive trend. Okay, it will be negative trend. Okay, let me check.
Then the other thing I noticed is, if you see after I've run the code,
yeah,
sometimes when now you want to run it, it will show you this kind of thing, too many concurrent images.
Aggregation. Yeah. So for that, I think for the some networking issue, we face this type of result. Okay, for the networking issue. And if your code is very big and there's a lot of data set, then you'll also face this type of problem. Okay, too many concurrent.
So is it because we are not paying for the service?
Yeah. So that's why we find out this type of result.
Is it expensive?
Yeah, every month we need to pay. We take the subscription. So it also okay, no problem. Free version you cannot do, but you can run it, then it will be work, no problem.
All right, okay. So I will share the other code and see what
Yeah,
it is.
you can also send me the code, then I try to check what happened. It show the positive trend. Yeah.
All right, so you also asked some questions about the confidence level, why, and you need to explain a little bit about.
Okay, you can send me this. The review paper also. Then I'll try to check it.
All right.
Okay.
Yeah. All right. Okay.
Okay. Thank you.
All right.
Okay. Any question? Okay, so I'll send you the all of today's session recorded class, and I'll send the all of materials. So further, let's ready to check and also read some scientific paper, and then also try to publish this type of topic of work. Okay, so today is no more, and next class will be held on the next Monday, inshallah. In the meantime, you can simply contact in my WhatsApp for any problem. Thank you. Have a good night.
All right. Okay.
Bye.
Yeah, thanks. Thank you.